Hi, everybody. What I wanted to talk about with this, I wouldn't even call it a lesson, but just a little bit of kind of a tip, a little piece of advice, maybe a wider perspective on some things, is that after we get reintroduced to our sine and our cos graph, particularly, those two curves are ones that we should be working at to the point where we are really, really solid with those. Our tan curve, that one's always going to kind of feel a little less confident just because we don't use it as often. But for our sine and cos curves, we should be pretty automatic. That what I wanted to do is I just wanted to kind of go back a little bit and readdress some of the material that we would have gone through kind of in the last section. And just to kind of expand on what do I think is the most ideal way to solve certain problems. Now that we have the curves with us as a review, and we have all of our rotation angles, maybe there's some ways that we can split the difference. So when are we most efficient to work with one versus the other? So first thing I want you to take a look at, on the page, put down a quick sketch of your sine and your cos curve. What you'll end up having then is a curve that should roughly fit the shape of it. And I'm going to argue to you, you should be able to get down that curve between 10 to 15 seconds. So, as an example, if I take a look at my sine graph and I was to begin that curve, I say, okay, I know that my sine curve starts in the middle and rises. So I know that then I hit my maximum at pi by 2, my 0 at pi, my minimum at 3 pi by 2, my 0 at 2 pi. And then I connect it with a smooth curve. And if I get used to curving down for that whole first half of the rotation, and then curving up for the second half, I put down a pretty useful sketch in 10 to 15 seconds. Now, I was probably 15 to 20 seconds, but if you consider all the blabbing I'm doing right now, you guys would be much faster. So let's give it a shot right away. On the second grid, what I want you to do, put on a quick sketch of your cosec's. Okay, pause the video now, we'll see if we match up. Okay, we should be back. So we should know that our cos curve starts at the top and falls. So I hit my next 0, my next min, my next 0, my next max, and when I have curve down, curve up, curve down, I get a pretty useful curve quickly. Okay, super. Now what I want to do is kind of, with those two things in mind, let's slide in and look at some problems that we would have seen in our last section. So if you take a look at problem 2, I'm asking you to determine the exact value for this. Now, what might pop up first off is that this was a problem that we asked you last unit. Secondly, though, it may have been a problem that might have been a bit of a struggle. So the fact that if you were to solve this using rotation angles, you're saying, well, I know that that's 3 pi by 2 if I rotate, but because my terminal arm finishes on an axis, we may have had a little difficulty in trying to come up with the ratio value. What I would argue to you, don't bother. Instead, if we know our curve well enough, let's just use our curve. So when we take a peek at that, you would then say, okay, here's my quick set of axes. I'm talking about my sine curve. And so I know sine starts in the middle and rises. Max at pi by 2, 0 at pi, minimum at 3 pi by 2. And I know the minimum value of my sine curve. And so very quickly then I can simply write, done. Using my curve can be really quick. You'll notice the same thing in B. How do I have my focus with it? I look at my angle. And as soon as I see that that angle would finish on an axis, or with the standpoint of my curve, as soon as I see that my angle puts me on one of my quarters, then I'm going to use the curve. So I know my cos curve starts at the top, falls. Hits my 0, hits my minute pi. Well, my minimum value, there we go. So in A and B, I would be using my trig curves every time to go through and find those values. But now when you take a look at C, you'll notice a different situation. 4 pi by 3 is not a key value on my trig curve. It's not a max, a 0, or a min. It puts me somewhere in between. And if I do get somewhere in between, then what I'm going to focus in on is using rotation angles. I know that then I would have to rotate here, which would give me a pi by 3 related acute angle. So construct your triangle, negative root 3, negative 1, 2. The sine of it then is equal to negative root 3 halves. So I don't want anyone to think, oh, so we should just be using our curves all the time now. Not at all. To me, if your angle is one of those key values, use your curve. If it has you fall somewhere in between, use your rotation angle. And then we start to become efficient and quick with it. So let's take a look at the last three as well, and we might come into even more of a reason for why we might want to use our angles and our curves. So when you take a look at 3a, you'll notice I have angle x. Angle x puts me on an axis. So rather than saying to solve every trig equation, I always use my curve, instead I'm going to go, okay, that question tells me the sine of some angle gives me 0. So I think about my trig curve then. When does my sine curve give me a 0? Well, I know my sine curve starts at 0, so there's one of them. It then rises, max at pi by 2, back to 0 at pi. Minimum at 3 pi by 2, back to 0 at 360, or 2 pi. And so when we get to that case then, where we see the restriction of 0 to 2 pi, I have my answers on my graph very quickly. I can then say that x has to be 0, pi, or 2 pi. So there was an instance where that might have been faster using your curve. I'm not saying it is for everyone, but that might have been. You take a look at B. B is asking the same sort of thing. Now let me clarify. I circled the wrong thing, and it might have been a little confusing for some people back in A. Really what my focus should have been on is the value of that sine ratio. So let's take a look at B again. I notice that cos equaling 0, 0 is a key value on my graph. And so I think about my cos curve. My cos curve starts at the top and falls. Hits a 0 at pi by 2, minimum at pi, 0 at 3 pi by 2. And so I have my solutions again. Therefore, x equals pi by 2 in the first case, or 3 pi by 2 in the second case. Same thing as what we talked about in problem 2, though. That when you examine question C, that negative root 3 over 2, that's going to put me in between somewhere. And so I go back to rotation angles. I say my sine is negative, sine's opposite. So if opposite is negative, I must be going down. I can then construct my triangle. Opposite, hypotenuse, opposite, hypotenuse. That's going to tell me that my related acute angle then is a pi by 3. And so therefore, x is going to give me 4 pi by 3 in the third quadrant, or 5 pi by 3 in the fourth. And there we go. So a few examples of when is using the curve useful, but when is using rotation angles useful. Clearly your job would be to be fluent with both, but it doesn't mean that we're equally quick or equally confident with both. So maybe that just gives a little insight as to when we might want to use one curve or one option versus the other. Okay, your job now, jump in and take a look at the note for today's lesson. Work through that lesson as best as you can. I want you to make that lesson as useful as you can to you. Assume that you are getting no other feedback from me or no other lesson from me. Once you're done doing that, then hop on and take a peek at the adjoining video. Okay, best of luck with everything today.